I've been learning, yeah, so I've been learning a lot
The network.
of things, oh, that's okay, while preparing for the Mystery app. And what I'm doing to prepare for it is basically just compiling various apps. You know, they'll give me a wide range of experience, hopefully. So today I'm just going to share a few of the things that I've learnt. You probably might already know, but yeah, so I'm going to talk about code building processes, libraries, environment variables, and various make systems. It's just like a brief overview of everything. Didn't really go into much detail. So anyway, so how does source code become a program? Firstly, it's a two-step thing. So you compile and then you link it, and then it becomes an executable. So compilation actually refers to the processing of source code files and the creation of an object file. This doesn't actually create anything that the user can actually use yet. So it's like it's turned into an object code by a compiler. That's the first step. This results in an object file, so .o usually. And then after that, the object code is passed through a linker. A linker is actually a program that combines various modules and code files into an executable program. For example, if we compile but don't link 3 separate files, we actually have 3 object files created as an output, each with the name .o whatever or .obj depending on your compiler. So linking refers to the creation of a single executable file from multiple object files. It's quite common that the linker complains about undefined functions, mainly itself, or on the other hand, may look at multiple files and try to find references for the functions that weren't mentioned. So the good things about it is that the complexity of the program is reduced in the sense that by keeping functions separate, the compiler does its thing, the linker does its thing, it's easier to implement later. And also it allows the creation of large programs without having to redo the compilation step every time a file is changed. So we can use conditional compilation, to only compile those source files whose code has been changed, so we don't compile the whole thing. Also, it makes it simple to implement libraries of pre-compiled code by just creating object files, which treats it the same as any other object file. Knowing the difference of the compilation between compilation and linking stage is great because it can be easier to hunt for bugs. And compiler errors are usually syntactic in nature, so usually it's a missing semicolon or an extra parenthesis. Linking errors usually have more to do with missing or multiple definitions. For example, if I get an error that is a function or a variable defined multiple times from the linker, it's actually a good indication that the error is on like 2 of my source code files share the same name or like they're defined differently. Now libraries. A library is a collection of pre-compiled routines that a program can use. So the routines, sometimes called modules, are stored in object format. They're pretty useful in storing frequently used routines because we don't need to explicitly link them every time to a program that uses them. So the linker automatically looks in libraries for routines that it does not find elsewhere. An example of a library I downloaded was in one of the applications I've compiled. It's called CP2K, which is open source molecular dynamics. It's a program to perform atomistic and molecular simulations of solid state, liquid and molecular and biological systems, and required a library called FFTW. It's funny because it stands for Fast Fourier Transform in the West. I have no idea why it's called in the West, but apparently it's the fastest it's a software for computing discrete Fourier transforms. This is like the fastest one available. That's open source. And apparently it can compute transforms of real and complex values, arrays of arbitrary size and dimensions in O and log n time. I have no idea what that means, but I found this. I was like, oh, that's pretty cool. So I just put it in there. Another app I've compiled is called pFlowTran, which is an open source, massively parallel subsurface flow and reactive transport code. It solves a system of generally non-linear partial differential equations describing multi-phase, multi-component and multi-scale reactive flow and transport in porous materials. Yep. and parallelization is achieved through domain decomposition using the PETSI libraries. So PETSI stands for Portable Extensible Toolkit for Scientific Computation. So all these are a mouthful. And it's the building blocks for the implementation of large-scale application codes on serial and parallel computers. It uses MPI, standard for all message passing communication, and also it contains an expanding view of parallel, linear, nonlinear equation solvers and time integrators that may be used in application codes written in Fortran, C++, C and MATLAB. Yep. So more detailed information can be found in one of those websites. So in Linux, there are actually two libraries which can be created. So first one is static and the other one is shared. And the shared one branches out to dynamic linking and dynamic loading, which I'll go into later. So static libraries is actually a library of object code which is bound to the program at compile time, and it becomes part of the application. Well, this is good in small programs where minimal functionality is needed. Dynamically linked shared object libraries. It's actually loaded when application is loaded and binding occurs at runtime. So it can be used in two ways, either linked dynamically at runtime or dynamically loaded and used under user control. For programs that require multiple libraries, shared libraries can actually reduce the memory footprint of the program, both on disk and in memory at runtime. So this is because multiple programs can use a shared library simultaneously. So you see that program X and program Y, if it has static linking, each one of them needs to have their own libraries, but then if you have dynamic linking, program X and Y can share the same libraries. Because these programs can access the library simultaneously. So only one copy is needed. So some of the environmental variables, I think I started with path. Environmental variables are global system variables that are accessible by all processes running under the operating system. So they're also useful to store system-wide values, such as the directories to search for the executable program, this path. It's one of the variables that specify a set of directories where executable programs are located. So when a command name is specified or an executable is executed that's made from a program, the system searches through this path, examine it from left to right, and then it looks for a file name that matches the command name. So when I was compiling Fortran, I had to compile PETSI first, and I had to make sure that the paths of PETSI arc and PETSI dir were pointing in the same direction. So to do that, I had to echo that. I had to make sure that it was the same as the makefile, and if it wasn't, I just changed the directory to where it was in, to the correct location. The LD library path is a predefined environmental variable which sets the path with the linker that should look into it while linking dynamic libraries or shared libraries. It has the highest priority, so when it's set, the set of directories mentioned in this library path are searched first, even before searching the rest of the normal directories. So the best way to use it is actually to set it on the command line immediately before executing the program. You can set it as such, but obviously it's not a real example. The bash rc file is a file that the bash reads and executes commands contained in them when you log into the machine. So it's actually just shell commands typically used to change prompts, set environmental variables, and define shell procedures. Here is a copy of my current bash rc file, if you guys are interested. The bits highlighted in blue are the remnants of my internship over summer. Here I was setting paths for library and Python and all that, so that I didn't have to actually set it once I ran the program. So when you log on, the bash rc is kind of executed, so you don't actually have to type the commands in every time. one more thing that I was a bit confused about was the C flags. These variables can be set to specify additional options to be passed into a compiler during the process of building. These are usually set inside a makefile and are appended to the command line when the compiler is involved. Well, if they're not specified in the makefile, then they will be read from the environment if it's there. Most commonly used to specify optimization or debugging switches to a compiler. So I think I cover 3 make systems: make, CMake, and autoconf. So firstly, make automatically builds executable programs and libraries from source code by reading files called makefiles, which specify how to derive the target program. The purpose is to actually automatically determine which pieces of a larger program need to be recompiled after any changes are made in the source or header files, because recompiling the whole code just simply wouldn't make sense and it's actually very time consuming. So to use this, we'll need a file called the makefile that describes the relationship among files in the program and commands for updating each file. CMake is an open source build system. It's used to control the software compilation independent of the compiler. It's cool because it supports static and dynamic library builds, and it actually was created in response to the need for a powerful build environment for open source projects such as ITK and BTK. I think ParaView uses BTK. And finally, AutoConf. It's part of the GNU operating system, and it's a tool for configuring scripts for building, installing, and packaging software on computer systems where Bourne Shell's available. I don't think we have the Bourne Shell on Epic.
Yeah, Bash is the born again shell.
Oh, is it? Born again shell. Okay.
Little
Cool.
nerd humor there.
Alright. So the developer specifies the desired behavior for the configure script by writing a list of instructions in GNU M4 language in a file called configure.ac, which is second from the top. And then AutoConf transforms the instructions in configure.ac into a portable configure script and eventually spits out an executable. Yep, so this ends my awesome adventure for now.
Alright, does anybody have any questions?
Could you go over the bash thing again? I wasn't sure.
The bash.
Listed it.
This one?
Yeah. So like you've got a bash file there, bash rc.
Yep.
So you're saying that gets automatically run when you log on?
Yeah.
Did you say? So every line of code in there gets automatically run when you come. So what have you got in there? Like I can't really read it, but you've got a Q sub for.
Yeah, I've got
Is that submitting 2 different jobs at the same time?
No, it's like a link. So when you're on the terminal, when you do QID, it actually reads your command in here, so you don't have to type out select one and see and
Okay, no, I get that.
So it's like a shortcut.
I just thought it was automatically giving you a job when you logged on. Okay.
No, but you
it's
can.
just when you type QID, it
Yep.
writes that whole line of code for you.
Yeah, and
basically
it submits it. Yeah, and Q and
WQ3. Okay, it's the same. Yeah.
Yeah, and also
You could do that if you wanted to,
But yeah, what's the point?
you can also like load modules in there as well. Like that you definitely need, like other than PBS and Gold and Intel and
yeah,
yeah.
like module like Kilo.
Yeah.
So.
Yeah, it's just kind of like a shortcut.
Does your WQ3 work?
Yeah. But sometimes have to wait really
That's
long.
not debug Q though, is it?
No.
Okay.
Okay, I've got a question. What does that line place equals free colon EXCL do?
Place equals free.
Where?
It's in the QID, the second line, start of the second line.
Oh yeah, I've not come across it in the interactive job in the red. It's that second line under QID.
QID. Place
Okay.
equals free.
Yeah.
Yeah.
And then X, C1.
Excluding. Oh, I think it's trying to use. It's specifying like how many nodes to use or something like that. Rebecca, help. I think. Wasn't
So, place has to do with how it's going to place your request on the nodes. So, if EXCL there means exclusive,
You've done something.
so it means that you're going to take up the whole node, you're not going to share it.
Okay.
Sure.
Any
I'm gonna write that down as well so I can remember.
Any other questions? You can look it up, you know, if you do man QSub, you can find it also.
Okay.
Find what everything means.
That's not what-
So, are there any other questions?
No? Cool.
All right, well, thank you. That was very good,
That was awesome.
very informative.
I also got the one line.
Yeah, lots of
Don't want people sharing
there's so much information out there.
All right, my silly
That's okay.
thing here, I'm trying to
Is there
stop.
that line, you know, how little script thing so that
Oh, yeah.
I don't share mine with the people.